Okay, moving on to number 5, we read, an important number in mathematics is the number pi. If you've never seen that symbol before, this is what pi is. Oh, I lost my pen. Let's write it over here and say, well, what is pi? Well, pi, we know what pi is, right? We eat that. There's apple pie, cherry pie, pumpkin pie. Well, that's not it. Which leads us to also wonder how they came up with the pi, and it's not P-I-E. This is P-I, okay? But it could be because the person was looking at how they attain pi, or how do you get pi? Well, let me show you what it is. Let me draw for you a circle, or at least hopefully it's not a perfect circle, but it'll do for now. And what this circle has are two measurements that we know. One of the measurements is the diameter. Okay, so if we measure from one end, if you cut it directly in half, that measurement, the furthest ends, and you can go any direction and you'll find the diameter. Okay, then there's also what's known as the circumference, and the circumference is really the measurement all the way around, sort of like the perimeter of a box or a square or a rectangle. Shouldn't use the word box because that's three-dimensional, but the perimeter of a square or a rectangle, or of anything really. But this is the circumference, so that's that measurement, and this measurement are used together. All right, so let's just call this C and let's call this D. So what is pi equal to? Well, pi is equal to the circumference divided by the diameter. Okay? Now, what happens particularly because you're locked into whatever circle you draw, depending on the size, obviously a larger circle will increase circumference, but so will the diameter. And such that it will do so proportionally and equally, no matter how big or how small you make it. Meaning that this actual measurement is going to always be exactly the same. Pi, if we were to write it, we could never write it. It's irrational. There is no end to pi. And we're expressing it here as 3.141592. But you know what? You could go on and on for the rest of your life and calculating to each number, and it will never, ever be a finite number. You'll never be able to exactly write pi, only because this is a ratio and it's irrational. And you say, well, why are we dealing with irrational numbers when we're talking about rational numbers? Well, we can use pi for the sake of approximations, because pi is always used in calculations because of its properties and what it's measuring. For instance, if we had the circumference, we could determine what the diameter is. And if we had the diameter, we can determine what the circumference is. You might say, well, how does that work? Well, we'll show that a little later. We'll go on to the exercise and show you. But the one thing here is that we can see that these numbers can be rounded either up or down, and that's what we're being told to do. So we're asked to round pi to the nearest integer. So a would be to the nearest integer. And if we look at 3.14, we see 3.1. Well, we know it's closer to 3, so the answer to a would be 3. B is to the nearest tenth. So the tenth would be this position here. So we have to look at 3 point what? We can say 3.1, but we have to look to the right of that that particular unit, that tenth, and see, is it higher than 5, or is it 5 or higher or below? And then we see it's a 4. So we would say it's 3.1. Let me just reiterate again. If we're looking on a number line, right, and we had a big number line here, and we had 3.1 and 3.2. We know that pi is we know that pi is somewhere in between 3.1 and 3.2, because it's 3.141592 and so on. So let's take a look and see. Well, it's 3.1 and there's a 4. So 5 would be here, 3.15, right? Well, it would be to the left of that. This would be the midway point. So we see that it's closer to 3.1 than it is to 3.2. So again, we're rounding the unit that's to the right of the unit we're trying to approximate to. Now let's see what the next one is. The nearest hundredth. That th can certainly roll around when you're saying different words, tongue twister. But nearest hundredth. Now the hundredth would be here, right? That would be 3.14. But what's to the right of it? Oh, it's 0.1. So because it's not 5 or more, we would then say 3.14, right? 3.14. That would be to the nearest hundredth, not nearest hundredth. Now let's move on to D. D is to the thousandth, the nearest thousandth. Now the thousandth is here. Now what's to the right of it? Now we have a number, 5. It's much greater than the other numbers we're dealing with. In fact, it's right at the border. It would be right in that midpoint, and we say that we're going to round up. So we're rounding 3.14, and that 1 now becomes a 2, okay? Because the 5 next to it would make us go up one unit. So we have 1 becomes 2. Now let's take a look at, E. And E is 10,000th. Now 10,000th is the 5. So we have tenths, hundredths, thousandths, 10,000ths. That would be the 5. Now we look to the right and we see a 9. In fact, it's going to be so close that it's really, you can see how clearly that's 3.14. Now be careful here. This is not 2 anymore. We're going back to the original number. This was the answer here. We're not using these. These were just their answers for each of these. We're going back and saying 3.14159, which would now be 6. Okay? So just be very careful you're not referring to this. This has nothing to do with this problem anymore. We're going back to our original number. And so this would be to the nearest tenth, hundredth, thousandth, 10,000th. So that 9 is raising the 5. Now let's go to our last one, which would be the 100,000th. And let's see. Again, we'll go back to our original 3.14592. Now it's a 2. The 9th would be the 100,000th. The 2 being smaller than 5 means we would keep it just as is. So it's 3.14159. Again, this is to the nearest 100,000th. Okay, let's put our check marks here. And again, these are all different. Do not build off of the other. We're not trying to approximate off of an approximation. We're just taking the same number and we're going to give this number in each of these approximations. Okay, and pi is a wonderful number to work with because it never ends. You can go on and on and on. In fact, you can probably make a reference to this in many ways of not being the number you could define, but it's so useful. And as I said, we would take a look at this. Let's see, put a new screen up here. See if we can put clean this area out and just show you why these numbers or why this ratio can be used to determine or find the actual. I should have probably kept that. Just cleaning up my board. This is my little eraser, and I think that'll probably be clean enough. Now we know that the number pi is a number that we can write to a certain point, and that was 3.14. Let's write it down over here. 3.141592. Now, I know that's equal to the circumference divided by the diameter. Okay, that's the formula. And this is a formula. We talked about formulas. This formula is constantly being used to find a measurement such as the diameter or the circumference. So if you had a circumference, okay, let's say you had a circumference of, let's say 3.14, right? So we can say, now the question when we're dealing with pi says, well, what number would we use to determine what the either circumference or the diameter is? How far do we need to go out? Well, depends on how much or how precise we need the measurement of either diameter or the circumference. So you might say, well, I just need it out to the hundredth, okay? And that would be up to here. So let's say we had a circumference. I'm going to use a circumference of, so we say 3.14 is equal to, let's say the circumference was 314. I'll use that as a simple measurement for our math. Okay, so the circumference is 314 inches, let's say. Okay, so that's pretty big. That means if you were to measure this, if you were to roll out this circle into a long line, okay, that would actually be 314 inches, right? So, but we know that if you divide the circumference by diameter, you would always have 3.14. That would be your number of pi, because this is something that we've already determined. That is the ratio. So what number do we divide by 314 by to get 3.14? And that number would be 100, right? So if we were to write 3.14, excuse me, 3.14 is equal to 314 inches divided by 100, that would give us 3.14. That's a 1. And so we could determine that the diameter, if the circumference is 314 inches, then the diameter must be 100. Okay, and that is to the hundredth, 3.14. Now, this is a very simple example. Might have been better to have used, let's say, 628, right? Let's say 628. Now you'd have to ask, well, what number do I divide 628 by to get 314? Well, you can actually just divide 3.14 into 628, and the answer would be 200. Okay, so you divide. So the diameter would then be 200. So again, I'm just showing you a little application here to finding values for the unknown. We've already done that with x and y's, haven't we? And we've determined what y is if we know what x is in a formula. In this case, we're using other variables, and this is a more practical application. Hopefully, as you go on further in your math and science lives, you'll be able to utilize this knowledge that you're gaining. This is very fundamental knowledge. You're going to need to use this knowledge to build your knowledge in other areas. So, okay, let's move on to our next problem.